Hello everyone. In this video, we will be talking about solar power and the challenges it has. Just a quick introduction of what solar power actually is, or solar energy. Solar energy is a radiant light and heat from the sun that is harnessed using a range of technologies. The energy conversion process occurs in accordance with the 0th law of thermodynamics, and it also is in accordance with all 3 laws of thermodynamics, which will be discussed later in this video as well, more in depth. Some examples of solar power devices are solar panels, space heating and cooling, solar water heating, and many more different devices in everyday life. And then, like I said in this video, it'll mostly be with just solar panels. Thermodynamic process of solar power. All solar power comes from energy, and there are 3 laws of thermodynamics that relate to the energy involved with solar power. And that's like what I said previously, is that it is the 3 laws. It's the first law, the second law, and the third law. And that's what we will be talking about in the upcoming slides. The first law, the law of conversion of energy, states that energy cannot be created nor destroyed. It can only be transformed from one form of energy to another form. An example of this is combusting fuel. Converting chemical energy and fuel into the thermal energy. So basically, it's taking 204 kilowatts of chemical energy and only 274 kilowatts per hour of chemical energy, while only 274 kilowatts of useful heat energy can be transferred in a 90% efficiency boiler. This equation can be calculated by chemical energy released equals enthalpies of new bonds formed minus the enthalpies of bonds and fuels. That is the first law. The second law states that entropy invariably increases in a closed system. Ultimately, the second law effectively says that an energy consumer process will be less than 100% efficient, which is what we see mostly in a heat pump, which I will talk about later in this slide. But mathematically, entropy is defined in the context of Carnot cycle heat engine. The Carnot cycle heat engine does useful work by transferring heat from a heat source into a cooler reservoir. That equation can be shown to the right here, where S is entropy, and then KB times the natural log of omega. So an example I'm going to use is a heat pump. A heat pump will generally yield 2 to 8 units of useful energy per unit of energy that is supplied in the forms of electricity. The heat pump uses diffuse energy to absorb the heat and then compresses it into then release the heat. Therefore, it can move that diffuse heat, but the problem is that it is at a low grading energy while it is moving. So once it gets to the end of that process, it's very low grade and not as efficient as we would like it to be. And then the third law. The third law states that a system's entropy approaches 0 as the temperature approaches absolute 0. Therefore, referring back to the second law of thermodynamics, it is not possible to lower the temperature more than absolute 0. And the more entropy created outside of the cooled substance is then removed from that said cooled substance. I would like to put an example, but it is very rare to have this type of example in everyday life. But it is obviously expressed theoretically, as I just told you. But the most common law that is used in solar power process is the second law. The heat pump example is one of the best ways to describe it on a smaller scale. The overall message is that the efficiency of converting the solar energy into electricity is a main challenge. But there are other challenges that are also accompanied with it as well that my peer Brian will also take over and talk to you guys about it in the future.
There are many challenges that solar power face compared to other energy sources. One challenge of solar power is the inefficiency of it compared to other energy sources. The reason for its inefficiency is that it is unreliable due to being largely dependent on weather conditions, the location of the solar panels, and the time of day, factors that are all inconsistent in terms of attaining solar power. This can cause a demand for more power when the solar panels don't produce enough power when the time is needed to use more power than usual. Some of the other energy sources do not rely on weather and time variables, which are uncontrollable, and they can therefore maintain their source of power consistently. In addition, solar power is not able to convert sunlight into electricity. When photons from the sun hit the solar panels, only a part of those photons are absorbed and converted into electricity. The rest of the photons are either absorbed but not converted to electricity, or they bounce off the solar panels, similar to a reflection. Moreover, the solar panel's main material, pure silicon, is a material that is not efficient with absorbing photons from the sun and converting it to electricity. This is because silicon's semiconductor properties and its pure crystalline properties make it a poor conductor of electricity. Also, solar panels will degrade over time due to being outdoors and being subject to weather conditions, and will therefore decrease the efficiency of solar panels. Another challenge of solar panel is its high cost compared to other energy sources. The reason for its high cost is that the materials to build the solar panels are expensive. The materials that are used to make solar panels are pure silicon, inverters, wiring, mounting hardware, and batteries, which are the main components that make solar panels expensive. Another reason for the high cost of solar power would be needing to replace solar panels that are worn out, which means getting new solar panels, which would be quite costly. Furthermore, would be the cost of maintaining solar panels over time by replacing parts, cleaning and inspecting. Repairs and regular maintenance costs can add up over time. Additionally, storing energy to keep as a power reserve for future use requires expensive battery systems. Another challenge of solar panel is the amount of space it takes up compared to other energy sources. There is a lot of consideration that can be taken into account for solar panels to be installed not only in a home but on land as well. The focus on space will be putting on solar panels out on a home. Generally, every square foot of roof space has a potential to generate around 15 watts of solar energy. Therefore, every solar panel installation needs a dedicated amount of space to be placed. For a small home, they might need around 200 square feet of space for each panel, while a larger home can require more than 1,000 square feet of roof space to offset the electricity usage. Also, the amount of panels to be effective for a home can be about 18 to 24 panels. That is under the circumstance that every panel is placed perfectly on the roof. If they are not positioned perfectly or optimally on the roof, there will be problems such as quality of the panels are standardly rated and that the location is adequate for sunlight year-round. That goes for not only being placed on a house, but on a field as well, which takes up lots of horizontal space compared to other energy sources. There also needs to be no trees, no shade, and no issues where they can be damaged. Another challenge of solar power is the amount of maintenance required to keep solar panels in good condition, which is higher compared to other energy sources. Some solar panels are not always consistent for the quality. Different companies use different qualities for each solar panel. In an ideal world, solar panel with good quality and great placement requires minimal maintenance yearly. For yearly maintenance, it requires only 3 to 4 times of cleaning. But for a normal situation, there must be way more maintenance for your solar panels. Some locations carry up debris and dirt that can be put onto the solar panel. Also, hail or snow or rain can be a factor that will disrupt the solar panel's efficiency for getting electricity into your household. Therefore, this requires maintenance to them yearly. In conclusion, the laws of thermodynamics of solar power show the limitations of the many challenges that this renewable energy source has in terms of efficiency, cost, space, and maintenance. Regardless of those disadvantages, solar power continues to be improved and shows potential for the future. With more people being aware of the environmental benefits that solar power provides compared to other energy sources, this could increase the demand for solar power. As technology advances, solar power is hoped to become a much more viable and sustainable energy source that rivals other energy sources in the future. Eventually, the future of solar power will be determined based on political, social, and economical factors of society.